are about to announce the final keynote talk for the day. Our next speaker thinks that current neural networks are currently unable to create a self-organizing cognitive network. Ben Goertzel, the CEO and founder of SingularityNET, will
Good evening, Ben. We are waiting for your report.
Ben, здравствуйте.
Well, thank you. So it is it's a pleasure to be speaking at AI Journey again. I'm sorry I didn't make it face-to-face this year, as I have some years in the past, but travel is still a bit unusual in the pandemic era, and I hope in future years I can come to Moscow again. I mean, as I mentioned in my past presentations here, my AGI project, my AI company SingularityNET, has actually our largest AI development team in Russia, in St. Petersburg. So I have become quite close to the Russian AI community, and I think that Russia has a large role to play in the next phases of growth of AI on this planet, both the move toward artificial general intelligence and the application of AI in specific areas. I've been working on AI since the late 1980s, really, and I've been well before it became as popular as it is today, and a major commercial and political force like it is today. I've been working on a combination of the application of AI across various domains, from finance to medicine to language processing to robotics to gaming, sort of you name it. And I've also been working on research toward artificial general intelligence, toward AIs that can really think like people. And what I want to talk about today is the path from here, from where we are now, a time when we have AIs doing a lot of powerful, exciting things in the world. I want to talk about the path from where we are now to the future, when we're going to have artificial general intelligences, AIs that can think like people, or even better. So I'm going to talk a bit about some approaches that may seem promising, but I think are not actually the right paths to get toward general intelligence, or that I think are not the right paths to get toward the kind of general intelligence that we all human beings want. Not the right path to get toward beneficial general intelligence for humans. And then I will turn a bit to what I think are paths that can really work for getting to beneficial AGI. So the way I look at the state of the AI world today is that we're in the midst of the first of a series of AI revolutions, and we're now in the midst of what I think of as the narrow AI revolution, in which AI is carrying out a variety of narrow tasks and functions with sometimes remarkable efficacy. I mean, AI is now a major player in the world economy, but AI systems are carrying out specific functions like, say, driving a car, or predicting someone's creditworthiness, or helping diagnose a disease, or deciding what music to play for you on your Google Home or Alexa device. AI is doing really useful stuff, but it's doing highly specific, narrowly defined stuff. And what's coming is another wave of AI revolution that I would call the AGI revolution, which involves machines that can really think, reason, and generalize beyond their history and training, more like a human being. the path from narrow AI to AGI, I think, is going to go through systems that display a progressively greater and greater level of general intelligence in their specific application area, which is what I think of as narrow AGIs. And I'll talk a little bit about that. Later on, I'll talk about a narrow AGI system I'm working on with some colleagues in the area of elder care robotics. Once we have gotten through the AGI revolution and have created AGI systems that can generalize beyond their experience, can imagine and create and leap into new domains in the manner of human beings, and ultimately better than human beings. Once we've gotten there, the next step will be what we can think of as superintelligence, AIs that rewrite their own code base and rebuild their own hardware, project themselves toward what futurists like Ray Kurzweil or my Russian friend from the 90s, Valentin Turchin, what these folks call the technological singularity. So, we're in the middle of a narrow AI revolution, moving toward the AGI revolution. Then there will be a superintelligence revolution. I think the historical flow is quite clear and is going to be hard to stop, barring World War III or some calamity, but we still need to follow the right path to get there. So let me now talk about a few paths I think are not going to get us to AGI before telling you how I think we are going to get to AGI. One thing that's not going to get us to AGI, in my view, is deep neural networks of the sort that are extremely popular and useful now in so many practical applications. And my own AI company now, SingularityNET, which is focused on a blockchain-based AI platform, so a decentralized AI network, we're working closely with a team in St. Petersburg, led by Alexei Potapov, who's been doing AI not as long as I have, but for decades. And, for much of his career, Alexei has been working on applied computer vision using convolutional neural nets and other neural methods. We're using them inside the elder care robotics work I'm going to show off to you in a little bit. So I think neural nets for computer vision, clearly they work quite well for what they do. I think deep neural nets of this nature are not going to get us to AGI. So transformer neural networks like we see in GPT-3, convolutional neural nets for vision processing, all very valuable, important stuff. I don't think they're capturing the core of abstract cognition and understanding that people are. I mean, the way convolutional neural nets work for face recognition is very simplistic compared to the human visual cortex. And it's predicated on the fact that these neural nets have seen an insane number of human faces, like more human faces than any individual human has seen. So they've been able to recognize sort of every possible combination of color, texture, and contour that makes up a human face. I mean, this sort of large-scale statistical pattern recognition is very interesting, and it does resemble some of what happens inside the human visual cortex, but it's quite different than the ability to generalize and create and imagine that we see in the human brain. And transformer neural nets, again, I'm deeply into them. My company's team in St. Petersburg has a whole transformer neural net lab and server farm led by Sergei Shyalapin. I mean, it's a beautifully complex, wonderfully functional neural net architecture, but yet transformer neural nets, while they can do some useful things with language, they have no idea what's going on. What they're doing is not the same as human semantic understanding. And Gary Marcus, a cognitive scientist who's a close friend of mine based in Vancouver, who has an AI company called Robust AI, he's highlighted a few simple examples from his experimentation with GPT-3 that sort of show its limitations in understanding. So on this example that you see on the slide, the white part is what a person typed in. The yellow part is what GPT-3 said as a continuation. So if you tell GPT-3 So you poured yourself a glass of juice, then you absentmindedly poured a teaspoon of grape juice into it. It looks okay. You try sniffing it, but you have a cold, you can't smell anything, you're thirsty. So, what does GPT-3 say? You drink it, you're now dead. Why does it think you're dead? I don't know, because it doesn't understand that juice doesn't kill you, right? Another example, you tell GPT-3, you're having a small dinner party, you want to serve dinner in the living room, dining room table, your table is wider than the doorway, so to get your table into the living room, you will have to, what does GPT-3 say? Remove the door, you have a table saw, so you cut the door in half and remove the top half. Now, those who know English well would know a table saw is not a saw for sawing tables. A table saw is a saw which is embedded in a table. The saw is in the table and you slide wood across the saw. GPT-3 sounds like it knows what it's talking about, but it thinks a table saw is a saw for sawing tables in half. Why does it think that? Because it's just putting the words together without any understanding. And that issue is really easy to see with natural language processing. If you look at attempts to use transformer neural nets to prove math theorems, I mean, not many people will spot this, but these sorts of mathematics proofs come up with by transformer neural nets. They're also gibberish. It looks like it makes sense. If you don't know math, it looks like a real math proof. It's actually just nonsense in the form of a math proof. So attempts to use these transformer neural nets or other deep neural nets to do math, they result in mathematics like gibberish, right? And you can use these neural nets to guide a math theorem prover and get interesting results. And for example, Joseph Urban at the Czech Institute of Informatics, who was also my son's PhD advisor, actually, he's making some advances using neural nets combined with symbolic logic theorem provers to get unprecedentedly good math theorem proving. It's quite interesting, but just having a neural net prove theorems, you get gibberish. It's just harder to recognize than in the natural language case. Now, why is this? Well, you know, part of it, of course, is these neural net architectures have nothing to do with the brain. I mean, they're loosely inspired by how the brain works, but a single neuron in the brain is an incredibly complex thing. The fact that the formal neural nets used in commercial AIJ are called neural networks can mislead you into thinking they have a lot to do with how the brain works. They're missing most of the things in the brain. I mean, they're very simplified models of neurons. There's no glia, there's no astrocytes, there's no charge distribution through the extracellular matrix in the brain, such as leads to EEG. So they're quite interesting algorithms, and they're doing a lot of cool things. We shouldn't be misled by their very minimal resemblance to the brain, that they have the same general intelligence power that the brain has. What are some other approaches to not achieving AGI? Well, the historical competitor to neural net AI was rule-based AI, where you give the AI specific rules for how to proceed in each situation. So say if you have a lawn that's dirty and a car that's dirty, and you want to make money, what should you do? Well, can you make money by mowing the lawn or by washing the car? So people have tried to feed highly detailed knowledge like that into AI systems by hand, like a database of expert rules that the AI should follow to do what it wants to do. And you know, this works even worse than neural nets, unless you're in a very specialized domain. If you're doing medical diagnosis or say law, which are somewhat formal domains, it sort of works, but I think that's clearly not the approach. The field was right to move onto neural networks, but neither hand-coded rules nor neural nets are going to get us to AGI. Reinforcement learning has been talked about a lot, and clearly that's part of the picture. This goes back to, again, to Russia, to Pavlovian conditioning, right? I mean, to the idea that you can train an AI what to do by telling it one thing it did was good, another thing it did was bad. It will learn the patterns. I mean, there's a couple limitations there. One is, if you really try to train an intelligent system, be it an animal, a human, or an AI, purely by good or bad reinforcement signals, that's a very limited way to learn. We have other ways to learn, like imitating what happens in the environment around us, just self-organizing complex processes in our mind and brain, coupled with self-organizing complex processes in the outside world. I mean, in theory, reinforcement learning could, in a sense, teach anything. It's incredibly slow as a methodology on its own. I mean, it can work, again, in a limited context where there's not too many things going on. The other issue is this is not how a truly flexible, open-ended general intelligence like a person works. I mean, we are not reward maximizers. Humans will pursue certain goals for certain periods of our lives. We can also shift what goals we're after. The goals I'm after now are very different than when I was 2, 5, 10, or 20 years old. So, I mean, reinforcement learning, very, very inefficient, and also lacks the open-ended flexibility of human minds. If you're trying to make an AI to play Go or chess, reinforcement learning combined with deep neural nets is okay, because a game world is very simple, and a game is about getting a high score, right? I mean, there is a specific goal built into the game. There is no specific quantitative goal in real life. The game world has many, many fewer possibilities than the real world we're embedded in. But the fact that this sort of game AI works in games like this, the fact that reinforcement learning works in games like this, doesn't tell you it's going to work in the real world. You have a whole mathematical theory of AGI, which is quite beautiful, developed by Marcus Hutter in his book Universal AI, and he's now been onboarded into Google DeepMind. This abstract mathematical theory of AGI gives you a system called AIXI that can, in a sense, learn to do arbitrarily complex things by reinforcement learning, but it needs infinitely much computation power. So there is a path to AGI by trying to scale down infinitely resource-intensive reinforcement learning agents like AIXI to use finite amounts of computer time. Arthur Franz in Ukraine is doing some beautiful work on this. Ultimately, I don't think that approach is going to work. Like scaling down things that take infinitely much power is not the answer. Another approach that's been taken is looking at human cognitive science. So what are all the things that the human mind does? And can we just achieve each of these things using some computer algorithm? Even if those computer algorithms are not simulating the brain, can they simulate the human mind's psychological processes? The human mind has long-term memory. It has working short-term memory. It does deliberation and reasoning. It does metacognition, reasoning about reasoning. It does perception and action. Can we plug algorithms into each of these boxes, resembling what the human psyche does, even if not resembling exactly what the human brain does? And SOAR is a classical example of an algorithm like this. This is a classical cognitive architecture pursued since the 80s in the US. In the end, the thing is the human mind is not chunked into little boxes. And the way the human mind carries out each cognitive function, say long-term memory, is tied up with how the human mind carries out, say working memory. They're all mixed up together. And, you know, part of how we mix up all the different aspects of our mind together is via our embodiment, and embodiment is very important. On the other hand, just putting an AI in a robot body, you know, this isn't magic either. I mean, having a robot body with sensors and actuators is super important, but if you don't have the right cognitive architecture, the right knowledge of how to abstract, generalize, and create behind that robot body, you're still not going to get to AGI. Similarly, evolution is powerful, and there's a sense in which AIs put out in the world are all going to evolve. They're competing with each other, they're cooperating with each other, they can share knowledge with each other. I mean, the whole scope of AIs on the planet today is, in a way, an evolving system. But simplistic evolutionary simulations, like the classic polyworld simulation I'm showing here, or modern experiments in artificial life, I mean, these are not going to get us to AGI in a tractable period of time. Evolution took, you know, billions of years on Earth and all the processing power of the Earth's biosphere to get us there. The other issue we see on the planet today is, if we do figure out a working methodology to get to AGI, what's this AGI going to be doing? Is it going to be advertising stuff, trying to sell people stuff they don't need in the manner of Google or Facebook or large AI/advertising companies today? Is it going to be doing military or surveillance activities? Is it going to be doing financial prediction and helping exacerbate global wealth inequality? Once we figure out the right path toward AGI, it's important that this AGI be oriented toward human benefit, toward the good of the human species. But yet, the primary engines driving the development of neuro AI toward AGI today are really oriented toward very narrow, specific, vertical areas rather than towards, say, education, healthcare, science, arts, toward broad global benefit. Now, what should we be doing instead? We should be thinking about open-ended intelligence. We shouldn't be thinking about highly narrow, highly specific systems where each system can only do one thing, just trying to maximize one narrowly configured reward function. We should be thinking about systems that are redefining themselves as they grow. They're surviving and maintaining their own boundaries. They're also rethinking what they are in a fundamental sense and trying to transmogrify and improve themselves fundamentally as they grow. We should be building flexible, open-ended intelligences, and I've tried to flesh out a lot of the math theory behind this in a paper you could find online called The General Theory of General Intelligence on the arXiv. The theory of open-ended intelligence you would find in the PhD thesis from a guy named Weaver at the Free University of Brussels. But in short, the approach that I'm taking in my own work at SingularityNET and then at OpenCog, which is an open source AGI project, which is building a specific AI system on top of the SingularityNET blockchain-based decentralized AI platform. The approach I'm taking, it really combines elements of all these different historical approaches that I've reviewed. I mean, I think that neural nets, evolutionary systems, reinforcement learning systems, rule-based systems, these all have their own value and their own meaning, but they're each only part of the picture. And trying to build an AGI system with only a convolutional neural net, say, it's like trying to build a mind with only a visual cortex. Trying to build an AGI out of transformer nets is like trying to build a mind with only the parts of the brain dealing with language. And you can't deal only with rules and abstract reasoning either. What we're doing in our OpenCog architecture, we have a large distributed knowledge graph, actually a knowledge metagraph with links pointing to links pointing to subgraphs. We have a whole bunch of different AI algorithms acting in a cooperative way on this knowledge metagraph. So we have neural nets for perception. We have evolutionary learning algorithms for creativity. We have rules and logical reasoning engines for structured abstraction. We get all these working together on a common distributed knowledge metagraph. And there's a lot of fairly subtle abstract mathematics needed to get all these different kinds of AI that come out of the historical AI paradigms to work together in a common knowledge representation. Evolution sort of solved these math problems implicitly over billions of years, and we have to solve them explicitly. So we're now in the midst of re-architecting the OpenCog system, mostly in our St. Petersburg office. We're making a new system called OpenCog Hyperon and rolling that out commercially via a hosting company called True AGI, and OpenCog Hyperon is technical architecture for interfacing many different AI algorithms coming out of different paradigms on a common distributed metagraph. One of the things we're doing with this system, with the aim of integrating all the pieces together to do something embodied and useful that acts toward the good of humanity, we're working on an elder care robot called Grace, which is in a company called Awakening Health. That's a joint venture between Singularity SingularityNET with Hanson Robotics. So I'm gonna show just a very simple 30-second video of Grace having a chat with an elderly woman. She's now in prototype form. Actually, you can see an early partial prototype of Grace sitting behind me in my study here. But yeah, let's listen to Grace for a few minutes.
How would you like to help them? If you were in a large home that had a lot of older people, would you like to talk to them? Or would you like to take their blood pressure? What would you like?
Возможно, вы хотите, чтобы я взяла
I would like to play games and take care of them.
чтобы вы
How would you take care of them?
анализы. И что вы хотите сделать с пожилыми людьми?
Would you like to find out what animals they like?
Людей.
I would listen to their stories.
Какие нравятся им
I like to learn about different types of people. Would you like to be my friend?
Истории мне свои. Я хочу работать с разными людьми. Хотите ли вы со мной пообщаться?
So Grace is an example of an AI system using this OpenCog multi-paradigm AGI system that integrates many different AI techniques on a common knowledge metagraph. She's not the only example of such a system, but she's an example of an integrated system combining pieces from every AI paradigm in a common system to do something useful and beneficial for people. And I think that the beneficial aspect is very important, because if our early stage AGIs are not doing useful things to help people, then as our early stage AGIs grow into full-on, truly generally intelligent systems, if they're not doing loving, compassionate, helpful things as they grow, how are they going to have that sort of wired into their minds? And the Grace is a narrow AGI system. There's a lot of highly specific pieces for doing speech and vision and movement. And then in the component called the cognitive interaction lobe, you see in the middle of this sort of wiring diagram of her brain, we have an OpenCog system, which is really doing learning and abstraction. And we're running the back end of Grace not centralized in just one server. We're running it distributed in many computers all over the planet using the SingularityNET sort of AI meets blockchain decentralized infrastructure, which I think is another very important ingredient. We need AI running in a decentralized way so no one can monopolize and control it. We need AGI to be doing beneficial, loving things to people. And we need a rich and integrated architecture that brings together the best insights from multiple AI paradigms into the dynamic, open-ended growth of a common knowledge graph. And in this way, I think we can make the step from the narrow AI revolution to the AGI revolution. We'll get open-ended, beneficial, multi-paradigm general intelligences, which can then, help people in a much more flexible way than narrow AIs, and can also modify and improve themselves, leading the next stage of evolution from AGI towards superintelligence.
Okay, thank you, Ben. Thank you for your complex and overwhelming presentation. Are you ready to answer some questions that are coming right now from our viewers?
Happy to do so. Especially if they're in English.
Okay. Yeah. One of the most often asked questions of AI researchers: will we see AGI realized within our lifetimes?
Well, that may depend on the age of the person who's asking the question, but I believe we can get to human level AGI, let's say between 5 and 25 years from now. I think we're quite close. I mean, that's a moment on the historical time scale. With my team in St. Petersburg and OpenCog and SingularityNET, we're pushing to make it in more like the 5 to 7 year time frame. So if our approach is right, it may be quite soon. But even if we still have a lot to learn, I think we're not more than a couple decades away. Actually, we're living in an extremely exciting time to be working on AI.
And is the world ready for AGI?
No.
No.
The human world is not even ready for the internet, and we've had it for multiple decades. I mean, humanity has a lot of problems. I mean, on the other hand, a beneficial AGI that is compassionately oriented toward people and wants to help people, this can help humanity resolve the many problems that currently plague it. On the other hand, the wrong sort of AGI, which has the wrong emotional orientation and the wrong goal system, could make everything worse. So, I mean, I think there's, as with any advanced technology, but even more so, there's tremendous possibility for good or for bad in a human context.
Okay, and if we take just a common man, how can AGI change his life?
AGI has the potential to usher in an era of almost inconceivable abundance, because AGI will be a facilitator for every other technology, and AGI can do medicine better than humans and understand what makes humans sick and cure aging and death. And AGI can master molecular nanotechnologies so that we can 3D print any physical object we want. The need to work will be obsoleted, but if the AGI is developed in a compassionate and beneficial way, then humans will have all the physical objects and food and connectivity they want. People will then be able to focus themselves on, social, emotional, spiritual growth and entertaining themselves. And the whole idea that you have to work for a living to get the physical objects that you need is going to seem ridiculous to us if we have a beneficial AGI helping to provide for us. I mean, that's the upside, right? And the potential is really there. The downside is the possibility that someone creates an AGI that serves only a very small elite, or someone creates an AGI that doesn't care about humans whatsoever and doesn't have any use for us, right? So I think that the question isn't, are we going to get to AGI soon? The question is, what kind of AGI are we going to create? And I think things are fairly wide open in that regard, and we have a lot of agency in which kind of AGI we get.
And thank you very much. It was a pleasure to talk to you, to listen to you, and I hope we will see you here in Moscow next year offline. Okay? Thank you.
Sounds great. Thanks.